Hi, welcome to Captain Georgia. This is a series for basic navigation. We'll be discussing latitude, longitude, how to find your latitude, how to find your longitude, how to utilize and measure latitude, and how to find your position on a nautical chart using latitude and longitude. Each lesson is approximately 3 minutes in length. Let's get started. So let's talk about longitude. Lines of longitude run north-south from pole to pole. They converge at the poles. They're considered meridians. So the first meridian, the prime meridian, starts our degrees at 0 degrees longitude. It runs through Greenwich, England, at the observatory where it all got started. If we go to the other side of the globe, the rest of that circle, this particular arc, is 180 degrees from the prime meridian. Longitude runs from 0 degrees at the prime meridian to 180 degrees at the international dateline east or west of the prime meridian. So our prime meridian is 0 degrees, and this is our starting point. Longitude has a lot to do with time. Based on our 24-hour-a-day clock and the Earth rotating one time in 24 hours or turning 360 degrees, every 15 degrees of longitude is the equivalent of 1 hour or one time zone. As we go from 0 to 15 degrees east longitude, we're an hour later. 30 degrees east longitude, we're yet another hour later. 45 degrees east longitude, another hour, and all the way around to the international dateline. Going west, we're earlier. So when we get to 15 degrees west longitude, we're an hour earlier. 30 west, another hour earlier. 45 west, another hour earlier. So longitude equals time. For every time zone away from Greenwich, England, we always add 15 degrees of longitude when we do our mathematics to figure out where we are. So if we're 2 time zones away, we add those 2 time zones. So the Earth rotates 1/360th of a degree every 4 minutes. In order to find your longitude, you need to know a couple of things. First, when is noon at your location, or local noon? Local noon is when the sun is directly overhead, not your clock hour. Second, you need to know when it's noon in Greenwich. You need to have universal time available on your boat. We need to know local noon precisely, or as close as we can get. We need to know noon at Greenwich. Then we just have to work out a time differential. If you reach local noon before Greenwich noon, you're east of Greenwich. Therefore, east longitude. If our local noon is after Greenwich, so we see the Greenwich UTC clock hit noon, and then our noon comes 2 hours later, we know we're west of Greenwich. So let's try to figure out where we are with our longitude. So first, we have our UTC, or Greenwich Mean Time clock, on our boat, and we watch for that, and it shows 12 noon. But according to our clock, it's only 8 in the morning, which means we're not going to reach noon until after UTC. Since it's after UTC, we are west of the prime meridian. At noon in Greenwich, our clock says 8 o'clock. So we know those 4 time zones need to be corrected for. And each of those time zones is 15 degrees. So we're going to add those 4 time zones together. Each of those time zones is 15 degrees. So 15 times 4 is 60. So our base position is 60 degrees west. Now we watch for local noon to occur. When local noon occurs on our boat, our watch says 12:30. That's 30 additional minutes. So since the Earth rotates 1 degree every 4 minutes, we need to figure out how many degrees are in 30 minutes. So taking 30 minutes, dividing by 4, equals 7.5. So we have to add 7.5 degrees to our initial 60 degrees west, giving us a total of 67.5 degrees west longitude, or 67 degrees, 30 minutes, 0 seconds west longitude, west of the prime meridian. That's our current location, our current longitude meridian. Our next step is to take this longitude data and the latitude data we learned previously and apply it to a chart, which we'll do in our next lesson.